Hello everyone, my name is Arda Göçer and I'm a freshman student in the Electrical and Electronics Engineering department in Bilkent University. Today I'm going to present my Physics 101 project, and my project is about the relation between rolling objects and the friction force. The purpose of this project is to show how the friction force affects the final velocity of the same cylindrical objects, which will be covered with three different materials, and I will use energy law and some formulas to find the final velocity of the objects. Required equipments for this experiment are three same cylindrical objects that have a radius of 0.03 meters, an inclined plane, which has the length of 1.197 meters, a tape measure, balance, a stopwatch, a rubber to cover the object 1, wood, the material of the object 2, and an island to cover the object 3. This is our inclined plane for this experiment. The angle of the incline is 3 degrees, which has the value of the sinus is 0.052 and its length is 1.197 meters. So when we calculate the height of the top of our inclined plane from the ground by multiplying the sinus value with the length of our inclined plane, we get 0.062 meters, and we will use this value when we apply the energy law. And this is our cylindrical object that has a radius of 0.03 meters. Firstly, I covered my cylindrical object with rubber, which has the highest coefficient of static friction. Then I released the object and measured its time until it left the inclined plane. After that, I used the original surface of the wooden object, which has the second highest coefficient of static friction. I released the object again and measured its time until it left the inclined plane. This time I covered the object with nylon, which has the smallest coefficient of static friction. And for the last time, I released the object again and measured its time. Because we assume that there is no work done by other forces, the energy is conservative. We use energy law to the objects one by one. And we know the moment of inertia for a solid cylinder and know to find the angular velocity by multiplying angular acceleration and time. And also we know the angular acceleration can be found with linear acceleration over radius of the cylinder. These formulas lead us to find the linear acceleration is 2/3g sine theta for all cylindrical objects. And in the end, we can use our knowns in these formulas. As we can see in the formula, all three objects have the same acceleration. And these are the reaching times of the objects to the ground. After applying energy law, we get these results for the final velocity. So this project shows us the relation between the rolling objects and the friction force, and proved our theory for the rolling objects, which is the object with the highest friction coefficient reached the highest velocity, and the object with the least friction coefficient reached the lowest velocity when leaving the inclined plane.